How are you everyone? My name is Samahati. I'm a teacher of physics. I'm here to teach you a lesson about motion under gravity. Once we say motion under gravity, this is a motion of the body under the influence of gravitational force. Once we say gravitational force, this is a force of attraction between two objects which has masses. We said that gravitational force is a force of attraction between two objects which has mass. Motion under gravity, it occurs only when we neglect an air resistance. But when there is air resistance, it affects motion under gravity. So motion under gravity tends to occur when air resistance is neglected. So once we say motion under gravity, example, when we drop the stone from the highest heights, it tended to fall downward the surface. This is due to the influence of gravitational force of the earth. The gravitational force of the earth tended to pull an object towards the earth's surface because gravitational force tended to be large for the object which has a greater mass. That's why the stone tends to be pulled downward because the stone has small mass than the earth. The earth has large mass. That's why object which has small mass tend to be pulled downward the surface. Also, when a ball thrown upward, or let's say this is a stone, when we throw this stone upward, it go, but when it reaches at a certain height, it tends to be pulled downward. This is because of gravitational force caused by the Earth's surface. We also say that the gravitational force, this is a force of attraction towards the surface. Also, when the fruits drop from the tree, as we know from our trees, fruits tend to drop downward and not upward. This is because of gravitational force. When an object dropping or falling down, it acquires an acceleration. That acceleration, we call it acceleration due to gravity. Why we say that it is acceleration due to gravity? This is because that acceleration has been caused by the gravitational force. That's why we call it acceleration due to gravity. And it's the value of the acceleration due to gravity. Acceleration due to gravity is the acceleration caused by gravitational force. And its value is approximated always 9. The value of acceleration due to gravity is equal to 9.8 meter per second square. Or we can approximate it is equivalent to 10 meter per second square. This is a value of acceleration due to gravity. It is always constant on the Earth's surface. Acceleration due to gravity tend to occur. Its direction is downwards because gravitational force tends to pull an object toward downwards. So its acceleration due to gravity, its acceleration is always directed toward downwards the Earth's surface. That's why when an object moving downwards the surface, the value of acceleration due to gravity tends to be positive 9.8 meter per second square or 10 meter per second square. But when an object moving upward, it tends to oppose the acceleration due to gravity, or it tends to oppose the force of gravity. The force pull downward, but when an object moving upward, it tends to oppose that acceleration due to gravity. So for the upward object moving, objects the value of acceleration to gravity to be negative 9.8 meter per second square or 10 meter per second square. So this is the value of acceleration due to gravity. Okay, let us proceed. Let's go to the free falling body. Free falling body is an object which is dropped freely when there is no force causing it to move towards the earth's surface. Example, when I pick this piece, this leaves, when I drop it, so they move because there is no force I have applied to push it to move down. That is a free fall board. Consider this stone. When I drop this one, this is a free fall board. Here, when I hold this one, after leaving this stone to move downward, initially they start with zero acceleration. We are in a free falling box. Free falling board. So once we say free falling board, the body moves when no force causing it to move downward. They follow free. When is the object move free? So its initial acceleration become 0 meter. Initial velocity become 0 meter per second. Okay. So from the equation of linear motion, we saw that first equation says that final velocity is equal to initial velocity plus acceleration times time. But for the linear, this is for linear motion. For the motion under gravity, it changes. This final velocity becomes equal to initial velocity plus the value of acceleration. It changes into acceleration due to gravity. But for the falling body, the value of acceleration due to gravity is positive. So become plus gt. This is the first equation for the motion under gravity. For the body moving downwards. Second equation. From linear motion, we say that second equation is equal to distance, displacement is equal to initial velocity times time plus half acceleration times time square. But for this is for linear. For the motion under gravity, it changes because this acceleration is due to influence of gravity. So this is called acceleration due to gravity. So we write that displacement is equal to initial velocity times time plus gt square. This is second under gravity. Third equation. Let's go to the same equation. We love these parts. Proceeding. Third equation, you say that final velocity square is equal to initial velocity square plus 2 times acceleration times displacement. But this is for linear. For the motion under gravity, we change the value of linear acceleration into acceleration due to gravity. It becomes that the final velocity square is equal to initial velocity square plus 2 acceleration due to gravity times the displacement. This is for under gravity. Example. Consider the following example. Let's Thus, a stone dropped from the 10 meter for the 2 seconds. Find its final velocity. Come to the solution. We write our data given. Let us move this part so we can love this part. From equation that a stone dropped from the height 10 meters for 2 seconds, or it takes 2 seconds to reach into the ground. Find its final velocity. Will equals which equation involves velocity between the first, the second, or the third. But the first equation was the motion on the ground. Says that final velocity is equal to initial velocity plus gt. This plus for the foreign object, this g we consider as a positive. So final velocity equals to, but as we know that for the body moving downward under the free fall, this means initial velocity should be equal to 0 meter per second. So here is 0 meter per second plus g. The value of g is always constant, which we can approximate as 9.80 meter per second square times how many time it takes to reach the cloud. But we have given 2 seconds, so we multiply by 2 seconds. This second cancel out to the second 1. So its final velocity is equal to 0 meter per second plus 9.80 plus times 2 become 2 times 8 is equal to 16. Okay, 1. 2 times 9 is equal to 19 plus that one become 90.6 meter per second plus 0. So its final velocity is equal to 19.6 meter per second. This is for the body moving under free fall motion. Means that it has been started as 0 acceleration, finally it become that 0 velocity, and finally they become has acquired 65 watts velocity. Let's go to the body moving upward. How can we solve the body moving object moving upward under the influence of gravity? For the body moving upward, because as we know that the value of acceleration to gravity is always positive when the body is moving downward, because the force of gravity tends to pull an object towards the Earth's surface. But when an object moves upwards, the value of acceleration to gravity becomes negative, because it undergoes opposite with the acceleration to gravity. That force of gravity opposes the motion of an object moving upwards. As we say, for the body moving upward, the value of acceleration to gravity becomes negative 9.8 meter per second square, or we can take 10 meter per second square. That is for the body moving upward. And for the body moving upward, it means initially we start by giving it force so as it can move upward. So for the body moving upward, we have a certain initial velocity should be there. So, but when we throw an object, it moves, but when it attains a certain height, we call it a maximum height. Maximum height, what is maximum height? Maximum height is a height